In August 2026, a sudden wall of water and debris ripped through the steep valleys along the Nepal-China border. In a matter of minutes, the flash flood destroyed roads, buried buildings in mud, and left over 160 people dead. Heavy rain was only part of the problem. Higher up in the rapidly warming Himalayan mountains, a massive glacier collapsed, sending an avalanche of ice and rock into the river below and creating a massive surge of water. Less than a year earlier, Cyclone Ditwah made landfall in Sri Lanka. Intense rainfall and landslides tore across 22 districts, destroying thousands of homes, wiping out smallholder farms, and severing critical transport networks. This chart plots the frequency and severity of natural disasters over the last 3 decades. It shows a clear, accelerating upward trend. Driven by rising global temperatures, these extreme environmental shocks are no longer rare 100-year anomalies. They are the new baseline. Because the global climate has permanently shifted, our approach to disaster recovery has to evolve with it if we want communities to survive the next storm. Historically, the immediate goal after a major disaster is to simply return everything to how it looked the day before. The instinct is to rebuild the same roads, the same bridges, and the same houses. But that original pre-disaster state contained the exact structural weaknesses that caused the infrastructure to fail in the first place. If a community replaces a washed-out bridge with an identical copy, that new bridge will wash out exactly the same way during the next major flood. Aiming for the old normal is a trap. True recovery means leaving those outdated designs behind and engineering infrastructure built for the climate we actually have. This philosophy is called Build Back Better. It originated from United Nations conferences in Hyogo and Sendai, where global leaders established guidelines for disaster risk reduction. The core premise is that the immediate aftermath of a crisis provides a rare, brief window of opportunity. Instead of patching the damage, communities can secure funding and public support to permanently upgrade their defenses. Take the Asian Development Bank's $200 million emergency assistance package for Sri Lanka following Cyclone Ditwah. This diagram shows 2 approaches. On the left is a standard road eroding under floodwaters. On the right is a climate-resilient road designed to survive that same water. It finances upgrades like active slope stabilization to prevent landslides and deepened drainage systems channeling heavy rainfall away from the carriageway. The same logic applies to the agricultural sector. By rehabilitating broken canals into reinforced irrigation tanks with modern water management structures, farmers can absorb excess floodwater and protect the national food supply. By upgrading these physical systems, a region guarantees it can take the hit from the next major weather event without suffering total structural collapse. But concrete and steel only make up half the equation. If a population is left with untreated trauma after a disaster, the community remains highly vulnerable, unable to coordinate when the next crisis hits. To address this, the Institute of Mental Health and the Temasek Foundation applied the Building Back Better framework to the human mind, creating this program. This graphic outlines their 3-tier approach to psychological resilience, operating across China, Indonesia, and Thailand. At the top is Level 1, Leadership Development, ensuring government officials integrate mental health into community planning. Level 2 focuses on a training of trainers model. It equips 120 multidisciplinary professionals, like psychiatrists, psychiatric nurses, and social workers, with specialized disaster response skills. Finally, Level 3 pushes that knowledge down to the foundation. Those professionals train a decentralized network of over 600 local teachers and volunteers, putting immediate emotional support on the front lines. These mental health networks act as invisible infrastructure, keeping the community cohesive and capable of responding effectively when the next storm arrives. A resilient society demands 2 pillars: climate-proof physical engineering to protect the body of the community, and a robust psychological framework to protect its mind. Combining these 2 approaches changes how we look at the timeline of disaster recovery. It is no longer a straight line with a definitive finish date where the work is simply done. Instead, this diagram illustrates how the timeline shifts into a continuous loop. Recovery becomes an ongoing, cyclical process of constant capability building and risk mitigation. As global temperatures rise and extreme weather events multiply, we cannot afford to wait and react to the last storm. We have to proactively engineer our surroundings for the next one. Rebuilding exactly what was lost is an attempt to salvage the past. Building back better is the only practical way to secure the future. A truly resilient society demands both of these pillars: climate-proof physical engineering to protect the body of the community, and a robust psychological framework to protect its mind. Combining these two approaches changes how we look at the timeline of disaster recovery. It is no longer a straight line with a definitive finish date where the work is simply done. Instead, this diagram illustrates how the timeline shifts into a continuous loop. Recovery becomes an ongoing, cyclical process of constant capability building and risk mitigation. As global temperatures rise and extreme weather events multiply, we cannot afford to wait and react to the last storm. We have to proactively engineer our surroundings for the next one. Rebuilding exactly what was lost is an attempt to salvage the past. Building back better is the only practical way to secure the future.